Hello, ladies and gentlemen. Welcome to Math 10C, Chapter 5, Lesson 2, Linear Functions. Today we're going to do several things. We are going to determine whether a situation represents a linear relation and explain why or why not. We're going to determine whether a graph represents a linear relation and explain why or why not. We're going to determine whether a table of values or a set of ordered pairs represents a linear relation and explain why or why not. And we're going to draw a graph from a set of ordered pairs within a given situation and determine whether the relationship between the variables is linear. We're going to determine whether an equation represents a linear relation, explain why or why not. We're going to match corresponding representations of linear relations, and we're going to explain why data points should or should not be connected on the graph for a situation. So, first and foremost, the graph for a linear relation is a straight line. For example, this graph represents the linear relation y equals 2x plus 2. Now, here we are. We start at y equals 2. We go over 1 and up 2. That's something to note. But that's more for later. Now, some other ways of representing linear relations. Words. 2 times x plus 2 equals y. The equation y equals 2x plus 2. A table of values. X is 1, y is 4, x is 2, y is 6, x is 3, y is 8, x is 4, y is 10, or ordered pairs, 1 and 4, 2 and 6, kept on going, 10 and 22 would work. Now, how can you tell if it's linear from the graph? Well, look at the graph. A straight line, like the first one here, is linear. That straight line can be going straight up, it can be going sideways. But when it's curved and not straight line, it's nonlinear. This is not linear, or nonlinear. Now, how can you tell if it's linear from the equation? Linear equations have a degree of 1. The variables have no exponents other than plus 1. So y equals 1/2 x minus 5. Now this is x to the 1 power. Y equals minus 3x plus 3.5. That's technically x to the 1, which is too lazy to write the 1. So they're linear. Now, y equals square root of x is not linear. Remember, that's x to the 1/2 power. 3x squared is nonlinear. X is not to the 1 power. Now, how can you tell if it's linear from the table? Well, the value of x increases by a constant amount, and the y value increases by a constant amount, except for horizontal and vertical lines. They're sneaky. I'll do those in a few minutes. So, linear. Plus 1, plus 1, plus 2. So, the x increases by a constant amount, 1, and the y increases by a constant amount, 2. And the same thing for this purple one. Plus 1, plus 1, plus 2.5, plus 2.5. Okay. The x increases by a constant amount, and the y increases by a constant amount. We look at the last example. Plus 1, I'm happy. Uh-oh, that's plus 15. That is plus 17. Yes. Nonlinear. Increases by not a constant amount. Okay. Now, graphing ordered pairs. The cost of renting a boat is $10 flat rate and $2 per hour. Draw a graph to determine if the relation is linear. Right. So, let me see. I'm guessing cost time. So, how many hours? 1, 2, 3, 4, 5, 6, 7 hours. Cost. 10. Let's see. No. Let's do this. $2 per hour. So let me see. 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Do $20. So we start at $10 flat rate, And then for $2 an hour, so at 1 hour it'll be $2 more, 10, 11, 12. At 2 hours, it will be $2 more, or 14. At 3 hours, it'll be $2 more, or 16. 18, 20. So, is that a straight line? Yes, it is. Yes, it's linear. Now, I did that kind of quickly, but I don't expect you to be copying this out. I expect you to be looking at it and go, oh yeah, that's how you do that. Okay? Now, match each linear relation with a possible representation of the selections that are given. Justify your choices. The pressure P that a scuba diver experiences underwater increases at a constant rate relative to the diver's depth D below the surface. Y equals 1/2 x plus 4. So there's a couple of equations. Which one of these graphs does it match up with? So, let's start. Pressure increases at a constant rate relative to the diver's depth. So which one of these could be pressure and depth increasing? So, here we go. We got two of them. Pressure and depth. Now, this one is constant. This one is a series of dots. So, which one of these is better shows you going underwater? I think it's B, because you can go down a little bit or a lot. But it would be a constant line. The data would be, oh dear, brain fart. I'll remember this when I'm talking about it. Anyway, just looking at options. Now, I'm going to say here, increase at a constant rate. So, let's look at some of these data. Any of these data points work? 1, 4, 1, 8, 2, 12, 3. No, I think that graph is the best. Actually, this table of values, if this is 25 feet down, that could be the pressure plus 25, 57, yes. That's 176. All right, so that's 75. 176 plus 75 is 251. 251 plus 7. This also could work. Okay, so you have to be careful here. Match each with the possible representations. Yes, B and F are best. Now, the other one, y equals 1/2 x plus 4. Now, let's look at this graph here. If x is 0, y is 4. Ooh, the table of values works. If x is 1, half of 1 is a half plus 4. Okay, this doesn't work. But this does, 4.5. Alright, x is 2. Half of 2 is 1. 1 plus 4 is 5. So, this graph works. Now, do any of these words, 1/2 numbers, half another number, increase by... Oh, this one works too. One number is half another number, increased by 4. Ooh. So, A and E both work with this equation. Nice. Sneaky. Okay. Well, this is what I think about continuous versus discontinuous data. Continuous data, there's information between points in the graph. You can connect the dots. For example, this graph here, face length compared to ear length. You continue to grow. As you get older, your ears get longer, and your face gets longer. Notice it's a continuous graph. You don't just stop. Discontinuous data, there's no information between the points in the graph. You cannot connect the dots. For example, number of jumps, total distance traveled by George the Frog. Number of jumps versus total distance. Frog cannot do 1/2 of a jump. Do 1 jump or 2 jumps. So here it's discontinuous or discrete. There's data points you cannot connect the dots. Is that it? Yeah, okay, that's it for me. So what I want you guys to do, go through this, look at it carefully. Got any questions, shoot me an email. Otherwise, Let's get the homework done.